Good morning, ladies and gentlemen. Welcome to week 2 of SAT Math Prep. We're going to continue to work with the writing linear equations topic this week. However, this week's paper is no calculator. You should be bringing your calculator with you to these sessions every week. But this week we don't get to use them. So make sure that you put those underneath your desk, because occasionally we are going to need to look at problem types that will appear on the SAT that you will not be allowed to use your calculator on. So these three examples today are examples of problems that you would not be allowed to use a calculator on the SAT. Now, one thing to keep in mind is that this is all based on linear equations. And linear equations, there's 3 different types of linear equations, 3 different forms that you should know from class. And folks, they are not on the reference sheet. Okay? They are standard form, which is in the form ax plus by equals c. Okay, a, b, and c would be whole numbers. Well, they'd be integers, so positive or negative whole numbers. A would be a positive number, and a, b, and c would have no common factors. That is not on the reference sheet. Example 3 has an example of an equation in standard form. So if you look down at example 3 on your paper, you'll see a standard form equation. Now that one is a lot less important than the other 2. Okay, everyone in here should be familiar with the idea of slope-intercept form, which is y equals mx plus b, where m is the slope and b is the y-intercept. And you should be familiar with, although you probably have less practice with, point-slope form, which is what we use when we are given a point and a slope. It says y minus y1 equals m times x minus x1. Any linear equation could be written in any of these 3 formats. It is much easier to use point-slope form when you are given a point and a slope. It is much easier to use slope-intercept form when you are given a rate of change and an initial value. So part of this is knowing which format to use and using the correct format. Okay, so let's take a look at example 1. In example 1, I'm going to try my best to point out the important information here. A television with a price of $2,500, that's going to be important, is being purchased with an initial payment of $250, followed by monthly payments of $100. Remember, that would be per month. It says, which of the following equations can be used to find the number of monthly payments x required to complete the purchase, assuming there are no taxes or fees? Now, what we should notice is that all 4 answers, they're all written in slope-intercept form. So, we should be trying to write an equation in slope-intercept form. Now remember that in slope-intercept form, the slope is a rate of change, meaning how much it would change per x, x being monthly, right? So what we've got here is the y is going to represent the total cost of the television, which we have in the problem. I've highlighted it in yellow, so the yellow number would go in here. Then we've got m, which is going to be, or x, which we've already said is the number of monthly payments. And we have there m attached to it. That would be the amount being paid per month. So once again, that value is in the problem, and we've highlighted it in pink. So that's where the pink number would be substituted in. Well, that leaves the b value. The b value is representing that initial payment, the amount that's paid the day this television is purchased. So that I've highlighted in green. That's where the green number is going to go in. So if we take our numbers and we plug them in, we should have 2,500 on the left side of the equation, but all four of the equations do have that, so that doesn't help. The monthly payment should be attached to X. So the monthly payment is $100, which means this 250X is not correct, and answer D is eliminated. And then we have the initial payment of $250, which means B should be positive 250. So if we look at our three options, we have three different intercepts. We have negative 250, we have 0, which was not even written there, but there's always an intercept, and positive 150, or 250. So the negative 250 is wrong. Specifically, the negative is wrong. So A is not the correct answer. There is an intercept, so 0 would be incorrect, so B is not the correct answer. The only one that has every number in the right place is example C. All right, let's move on to the next one. So on example 2, we have a whole different problem here. The table shows shipping charges for an online retailer that sells cellular devices. There is a linear relationship. That tells us that this is a line, which means we're going to do one of our three forms, between the shipping charge and the weight of the merchandise. Which function can be used to determine the total shipping charge, f of x, which is a fancy way of saying y, in dollars for an order with merchandise weight of x pounds? So your x is the first column, your y is the second column. Now, in your classes, we have hopefully found what we need to do from a table. We, in order to write a line, need to know two things. And this is the same two things every time you're trying to find the equation of a line. You need to know a point. We have 4 points, 1, 2, 3, 4, and a slope. So we need the slope. Well, the slope can be found by looking at the relationship between the points in the table. If we use our calculator, we can discover that in the first two lines here, to get from 5 to 10, we have an increase of 5. To get from 10 to 20, that's an increase of 10. To get from 20 to 30, that is an increase of 30. Over here in the y column, if we use our calculator, if we subtract 38.53 minus 23.53, we discover that the increase in the shipping charge from $23.53 to $38.53 is a $15 increase. We can do the same thing for the other two lines. We have a $30 increase between line 2 and line 3, and we have a $90 increase between lines 3 and 4. Now, the challenging part here is that does not seem to be a constant rate of change, but it is. See, when we do rate of change, we are always putting the change in the y over the change in the x. And if you check on your calculator real quick, you'll discover that if we take any one of these pairs, if we grab, say, these two, 5 and 15, and we plug those in here, we're looking at 15 over 5, which is 3. Okay, if we grabbed these two, 30 and 10, and we plug those in, that's also 3. If we plug in this last set here, 90 and 30, that is also the same number. All of those are equal to 3. So our slope is 3. Okay? Now we have a slope and we have a point. Now that we found slope, we have slope and point, so we should use point slope form. So that's y minus y1 equals m times x minus x1. The slope is 3, so that number goes in for slope. And the x1 and y1, we just need to pick any one of these points. It doesn't matter which one. So let's use the smallest one, okay? We'll call that point x1 is 5. Plug that in here. And y1, what color have I not used yet? Pink. There we go. y1 is 23.53. We'll plug that in right there. So that would give us y minus 23.53 equals the slope 3 times x minus 5, which is our x1. Now all we need to do is take this equation and convert it into slope-intercept form, which means we need to solve for y. Okay, that will convert it from point slope into slope-intercept. Okay, so we're going to solve for y. First step then would be to distribute the 3 because slope-intercept form does not have any parentheses. So y minus 23.53 equals 3x minus 3 times 5, which is 15. Now we still are trying to get y completely by itself, so we need to move the 23.53 to each by adding it to each side. And that gives us y equals 3x plus 8.53. Now remember that y and f of x, those are the same thing. So when we look at our answers and we see f of x, in our head we should have already replaced the y with f of x, which means that the correct answer is 3x plus 8.53, which is B. As soon as we had the slope, we could have gone over here and said that answer and that answer are not correct and gotten ourselves down to just those two options in the beginning. This is a test-taking strategy tip. All right, we got one more to go, and this is the easiest of the three. Which of the following statements is true about the equation of the graph, of the equation 4x minus 5y equals negative 7 in the xy plane? This is in standard form. But it's asking us questions about slope and y-intercept, which means we need to take this and we need to convert into slope-intercept form, which is really just solving for y. We need to get the y by itself. So we take that equation, 4x minus 5y equals negative 7, and we need to solve for this y. So to do that, we need to get this term by itself on one side of the equation. So we subtract the 4x so that it goes to the other side of the equation. That would make this negative 5y equals negative 4x minus 7. And then we divide all three numbers, both sides of the equation, so everything, by negative 5. That gives us y equals, a negative divided by a negative is a positive 4/5 x. A negative divided by a negative is a positive 7/5. Now we don't really care what these values are because the question is not asking for specific values. It's asking, are the slope and the intercept positive or negative? So here we have a positive slope, which means the two answers that say negative slope are not correct. So A and B are out. And we have a positive y-intercept. So that rules out those two answers, one of which we've already ruled out. That only leaves one correct possible answer. The correct answer is C. This line has a positive slope and a positive y-intercept. Okay, folks, it's your turn now. On the back of the sheet are 4 non-calculator examples. So again, you are not allowed to use your calculator. Turn the paper over, complete as many of those as you can in the remaining time. Thank you for your time and attention.